This video is going to look at the motion graph story that you had on your test and look at the different questions along with the answers and how to find them. The first thing we're going to look at are the 6 different types of motion graphs that we learned about in class. The first one we're going to look at is steady speed, represented at A. Number 2 is, or letter B is rapid steady speed. If you notice, the slope of the line is just more steep than in letter A. C is acceleration, going from slow to fast. D is deceleration, going from fast to slow. E, a horizontal line, means no movement, so time passes, but distance doesn't change. And finally, F is return. For this problem, it had asked, what is the average speed of segment EF? So if we look on our graph, we have segment E is right there, and segment F is right there. If you remember, we learned about a circle in order to remember the different formulas. So for this, we want to find speed. Speed equals distance divided by time. So if we are to look at our segment, we're looking to see first the distance that it traveled. So if we look on our segment from E to F, the distance was 50 at E, and at F it was 20. So the difference there is 30, 50 minus 20. Now we need to look at the time, distance divided by time. So E was at 120. F was at 160, so the difference there is 40. When you do that math, it comes out to a total of 0.75 meters per second. So your answer should have been D. In this question, it says, what is the farthest distance traveled by the object pictured in the graph above? So this graph simply represents a person, an object, a car, something moved and took this trip the entire time. They want to know what's the farthest distance that they traveled. Meaning, here is your starting location at 0. What is the farthest point that we got away? If you look at our graph, our farthest point is at C or D. And if we go over across from there, that's a total of 70. So your answer should have been A, 70. This question says segment EF, which is right here, of the graph represents what type of graphic motion? So E to F, the one thing that we can see is that distance is changing. We have a curved line, so we know that it can't be anything constant or steady. So I'm going to cross that off. And one thing I want you to look at is, for example, the object traveled a lot of distance in a short period of time at first. So they were able to travel almost 20 meters in only about 5-7 seconds. Then eventually it starts to slow down. So this is the process of going fast to slow, which means deceleration. This would be when you're getting off the freeway. You're traveling at a fast speed, and now you start to slow down. For this question, it says, what is the total distance traveled in the graph above? So this object took a path along the way that took about 180 seconds. We want to know what's the total distance that they traveled throughout the entire trip. So if we first start and look from start to A, we can see that they traveled a total of 20 meters. So I'm going to write that over here. From A to B, the object did not move, so it's 0. Next, we look from B to C, and that was from 20 to 70. So that means it traveled 50 meters. Again, we have another horizontal line, which means no movement, so we're not going to add anything on. And now, even though the object is going back a distance, it's still traveling a distance. So this would be as if you're in your science classroom, you walk to your math classroom, and then you come back to your science classroom. Even though you're going back to your starting point, you're still traveling. So if we look from D to E, that went from 70 to 50, so that's another 20 meters. E to F went from 50 to 20, so that's another 30 meters. And finally, F to G, from 20 to 0 was another 20 meters. If you're to add this all up, you get a total of 140. So your answer was D, 140. How much time passes between BD? So B to D is all the way up there, and we want to know how much time passes. So we're first going to look at B, and we're going to see that it's at about 50. C is at 80. So from B to C, you have about 30 seconds. Now we need to know C to D. Well, C was 80, D was 100, so that's another 20. And if you add that up, you get 50 total seconds. Another way you could have looked at this is you could have just gone from B, which was 50. You could have found D, which was 100, and just subtracted. Same idea. The last one says, how long does it take the object to travel 90 meters? The one mistake that we saw often was that as soon as you didn't see 90 meters up here, you thought that it wasn't possible. So again, like I said earlier, you could be in your science classroom, travel to the math classroom, and come back. And even though you're going back, you're still traveling a distance. So if we look at our graph, we can already see when they get to point C, they've traveled 70 meters. So we already have 70. When they go from C to D, they don't change their distance, so there's nothing that we can add on. However, when they go from D to E, they are now traveling 20 meters right here. That means we've now hit 90 total meters traveled. At that point, what you would do is you just go straight down from E, and you can see that it took 120 seconds to travel 90 meters.